Hello everyone, welcome to my video. My name is Shaisa Kumar and I'm from SVC College. In this video, we will be learning about the scopes of different fields of civil engineering. Without further ado, let's begin. Before we start, let's touch upon what civil engineering is. So, what is civil engineering? Civil engineering is the oldest, broadest, and simple of the various engineering fields. It is mainly related to planning, analysis, design, construction, and maintenance of buildings, roads, bridges, dams, tunnels, and other structures, with the use of physical laws and mathematical equations and theory of mechanics. Contrary to popular belief, civil engineering is not only limited to analysis and design of various building structures. It also involves study of fields like geotechnology, hydraulics, transport. This is where we see the scope of civil engineering in various fields. Different fields of civil engineering: surveying, structural engineering, geotechnical engineering, hydraulics and water resource engineering, transportation engineering, environmental engineering, construction planning and project management, earthquake engineering, remote sensing, and GIS. The first field is surveying. It mainly deals with various types of measurements and plotting of maps. Surveying in civil engineering is the process of measuring and mapping the Earth's surface to determine the relative positions of points, angles, distances, and elevations. Without maps, no construction and development work can begin. So, surveying is an essential element of civil engineering. The main objectives of surveying are gathering data. This refers to collecting data using instruments like total stations, GPS, and levels. Establishing control points. Control points are reference points using which all measurements on a project site are taken. Determining property boundaries, setting out reference points, creating topographic maps, monitoring deformations. Monitoring deformations refers to monitoring structures and detect any deformations and movements. Common instruments used for surveying are chain, tape, compass, auto level, theodolite, total station, GPS, and drones. The next field of civil engineering is geotechnical engineering. It mainly deals with the study of soil, its types, and their properties. In building structures, the foundation is laid from a certain depth below the ground surface. The soil should be thoroughly checked for its suitability for construction purposes. The study dealing with the properties and behavior of soil under loads and changes in environmental conditions is called geotechnical engineering. Proper geotechnical engineering is essential for a safe and secure structure. Geotechnical engineering is also used to determine which type of foundation is required for a certain structure. It is also beneficial in design of dams, roads, transportation facilities, and underground structures. Uses of geotechnical engineering. These listed uses are the benefits of geotechnical engineering. Our next branch of civil engineering is structural engineering. It mainly deals with analysis and design of various steel and concrete structures like towers, buildings, dams, bridges, etc. Analysis refers to determining the internal forces or stresses developed in structural components due to the applied load. Design refers to finding the suitable dimensions like length, breadth, depth, and height for structural components using various methods. The uses of structural engineering are analysis and design of power generation stations and steel industrial structures, analysis and design of stadiums, auditoriums, and multi-storied buildings, design of nuclear power plants, repair and maintenance of structures. Our next branch of civil engineering is construction planning and project management. Development of new technology and machineries like cranes to lift the weight, painting machines, plastering, concrete and tar laying machines have been made. Have been made. This makes construction easier and faster. This branch of civil engineering involves tasks like excavation of soil, construction of foundation, concreting, and finishing using different techniques. On-site handling of construction and structures like buildings, roads, floating structures, underground tunnels using modern equipment will be looked after by construction planning. Project management refers to scheduling, planning, and execution of construction activities related to a project. It deals with labor management, materials required, time taken to finish a certain structural component, and most importantly, the expense management. Emphasis will be on new construction practices like precast construction and pre-stressed construction, safety of men and material, and utilization of marginal materials. Our next branch of civil engineering is hydraulics and water resource engineering. Hydraulics. Hydraulics involves the study of mechanics of water and its flow characteristics like pipe, pipe flows, dams, irrigation, open channel flows, etc. It is used to determine fluid properties such as density and vapor pressure. It is applied to design of valves, water gates, pipes, and other power system. Water resources engineering. It deals with tapping of storage water and supplying water to agricultural fields for cultivation, to drinking purposes, and to other domestic and industrial uses. Identifying, planning, and building water retaining structures like dams, tanks, and carrying stored water to needy area is known as water resource engineering. The stored water is then supplied for irrigation using different methods like sprinkler irrigation and drip irrigation. Water resources engineering also deals with water quality management and pollution controls. It is used to design weirs for dams, pumps, and turbines. Our next branch is transportation engineering. It plays a very important role in economic development of the country. It mainly deals with the study of existing transportation systems and their improvement for safe drive. It involves planning, design, construction, operation, and maintenance of transportation facilities like airstrip and runways, roads, harbors, and the laying of railway tracks. Traffic management, including traffic signals, number of lanes, width of roads, parking facilities, and curbs, are also a part of transportation engineering. The next branch is environmental engineering. This is an important branch of civil engineering which covers both water supply and sanitary engineering. The importance of clean environment was felt in the rapid growth of population and rise of urbanization and industrialization. Water supply covers tapping water from different sources, testing its quality, purification processes, and distribution of water to the consumers. The environmental engineers encompass the subject of treatment of wastes which originate from different sources and deals with removal of harmful substances in these wastes by different processes. The central government, state government, and local bodies have implemented laws for the protection of environment and all living beings, including humans. It is also branched out to complete various tasks like solid management, e-waste management, and construction management. Our next branch is remote sensing and GIS. Remote sensing is a relatively new field. It originated and is used in civil engineering due to advancement in space technology, availability of GPS, and an improved geographic information system. GIS is an high-tech equivalent of a map. It represents a means to locate ourselves in relation to the world around us. It deals with measurement, mapping, monitoring, and modeling of geometric and geographic information around us. It also allows us to send information accurately and quickly to effectively manage the available resources for optimal use. The key applications of remote sensing in civil engineering are topographic mapping, land use and land cover analysis, infrastructure planning, environmental monitoring, slope stability and geohazard assessment, water resources management, construction site management, traffic management, remote sensing in structural health monitoring. The last application of civil engineering is earthquake engineering. Earthquake engineering. Before learning about earthquake engineering, let's see what an earthquake is. An earthquake is a sudden, rapid, and violent shaking of the ground, typically causing great destruction as a result of movements within the Earth's crust or volcanic action. The scientific study of earthquake is known as seismology. Earthquakes and their impact is measured using a seismometer, and seismic waves are recorded on seismographs. The time, location, and magnitude of the earthquake can be determined using these seismographs. Earthquake magnitude earthquake of magnitude 2 and less are usually harmless and are called micro earthquakes. Earthquakes with magnitudes of about 4.5 or greater are strong enough to be called as a disaster. Earthquakes having magnitudes of 8 or higher are termed as catastrophic. The key applications of earthquake engineering in civil fields are seismic design of structures, retrofitting, foundation design, bridge engineering, risk assessment and mitigation, non-structural elements, seismic codes and regulations, earthquake research and innovation. Conclusion: civil engineers play a crucial role in shaping environment and improving the quality of life of people for people all over the globe. They work on projects ranging from small-scale residential buildings to large infrastructures, aiming to meet the ever-growing demands of modern society while considering environmental sustainability and public safety. They collaborate with architects, urban planners, environmental scientists, and other professionals to create innovative solutions for complex engineering challenges. Thank you for watching my video till the end. Like and share this video so that it can reach more people. Subscribe for more interesting content like this.